Hello everyone. In this video I want to look at solving trig equations. So we're asked to find all solutions to the equation cosine of theta equals 1/2. What I want to do is first of all understand that it's asked to find all solutions, which means we're going to have to set it up in a way that accounts for every possible solution. Since we're talking about 1/2, let's look at our 30, 60, 90 triangle. Remember, we have two choices when it comes to these exact values of sine, cosine, and tangent. They are 30, 60, 90 triangle, and the other is our 45, 45 right. In this case, I want to look at what angle measure could I use for cosine that will give me 1/2. Cosine being adjacent over hypotenuse, I can use my 60 degrees. So I can say that one of my solutions will be pi over 3. We want to put this in radian measure. Now it's not the only answer. The other possibility is 5 pi over 3. And the reason is, recall that since cosine is positive in quadrants 1 and 4. So if 60 degrees is our solution in quadrant 1, its equivalent, remember its reference angle, or negative pi over 3 in quadrant 4, is where I get 5 pi over 3. So these are my two immediate solutions. And when we look at finding the solution to cosine, sine, or tangent, we want to look at within 360 degrees, what are our possibilities? Now if we talk about all solutions meaning an infinite amount, we have to think, in addition to these, if I were to go around another 360 degrees, I'd have 7 pi over 3, and I'd have 11 pi over 3. If I went another 360 degrees, I'd have 13 pi over 3, and I have 17 pi over 3. And again, the reason is, when I talk about 1 full rotation, that's a rotation of 2 pi. Or since we have a denominator of 3, it's the equivalent of 6 pi over 3. That's how I got 7 to 13. I added 6 pi. Same thing with 11. Added 6 pi to that, and that's where I got 17 pi. So each time, I get a new set of answers by adding the period. Period of the function that I'm considering. So if I want to find all solutions, I'll start with my two initial ones. So we'll say pi over 3 and 5 pi over 3. And then to each, I will add. And let me make that more distinct. So pi over 3, and to that I will add 2 pi k, where k is a constant. That can be both positive or negative. That accounts for pi over 3, and then every iteration of that. 7 pi over 3, 13 pi over 3, and so on. And I'll do the same thing to 5 pi over 3, plus 2 pi k. And again, the 2 pi comes from the period of cosine. So if I ask for all possible solutions, this will be, or these will be my answers. Pi over 3 plus 2 pi k, 5 pi over 3 plus 2 pi k.